Hello, welcome to the second session in our Computing at Home series. This session is all about functions. However, before we learn about functions, let's recap on the commands we looked at last time. Commands are a set of instructions that we give to a computer to make something happen. Last time, you explored lots of activities to improve your use of commands. One of those activities was to make a jam sandwich. Many people made wonderful jam sandwiches, but did everyone follow the commands? The commands were: get 2 pieces of bread and a jar of jam. Put the bread on a plate side by side. Put the jam on 1 piece of bread. Let's pause there. As humans, we often fill in missing commands to make something work for us. I think there's a command missing here, but many of you filled in that missing command. You knew that to be able to spread the jam on the bread, you needed to open the lid of the jam. However, there was no instruction to do that. A computer cannot make the decision that you made as a human being. It would get stuck after step 2, or literally put the jam jar on the bread. Today, we're going to look at functions. When you're asked to brush your teeth, you follow a collection of commands. Pick up toothpaste, open cap, pick up toothbrush, position toothbrush, position toothpaste, squeeze toothpaste, stop squeeze toothpaste, replace cap, put down toothpaste, move toothbrush mouth, toothbrush rub teeth. Can you imagine if instead of your parents asking you just to brush your teeth, they said all these commands every single time? It would be unbearable. So when they ask you to brush your teeth, you should just brush them, because if they start to give you every single command, it's going to be really annoying. So we have the function brush your teeth, and we know all the commands to complete that function. The commands are the steps to complete the function. You'll notice parents are really good at giving function. Brush your teeth, get dressed, make your bed, set the table, tidy your bedroom. Of course, they think it's just one command, but it's not. It's a function, and it contains lots of commands to complete it. Sometimes hundreds of commands to complete the function. So you can see why children might object so much to being given a function, because it's a lot of work. However, I still think it's much better for your mum or dad or gran or brother or sister to give you a function, because if they spoke to you in commands, they would be going on and on and on. So let's have a challenge. How many functions can you think of in 1 minute? How many things do you do each day that take a lot of commands to complete? Here comes the 1 minute timer. How many did you get? Did you say any of these? Getting dressed, brushing your teeth, putting on your shoes, tidying your room, setting the table, loading the dishwasher, having a shower, making the bed, getting up. Lots of these take many commands, and you can think of the commands for each of those, I'm sure. So computers work in a very similar way. In Swift Playgrounds, the character Byte is unable to turn right, And the challenge within Swift Playgrounds is to make a function turn right using commands that Byte can do. So to solve that problem, to turn right, we command Byte to turn left, and turn left again. Then he's facing the right direction. You can also code using functions to create a movement or to turn an object. So to turn around, you could use the command turn left, turn left. Computers can only use commands they know to solve function problems. If you have an iPad, try the function exercises in Swift Playgrounds. Now, as humans, we can also be superheroes. Well, we can at least create super functions. And super functions are just made up of other functions. So if we take a function like morning routine, we know that this involves other functions. Get up, make bed, have shower, get dressed, have breakfast. Of course, your breakfast might look different to my breakfast. While computers can only do what we tell them, humans have very different ideas of what a function looks like when it's finished. Let's test this idea out with a simple function, paper aeroplane. Your job is to make a paper aeroplane. Then take a picture of the plane and share it on Google Classroom, Seesaw, or your class platform. Pause the video now and make a paper aeroplane. How did you get on? Does your paper aeroplane look like my paper aeroplane? Your function, paper aeroplane, may have needed different commands to my paper aeroplane. They may have been different folds. There may have been different commands. We all ended up with a plane, but they look different. We make a decision about the kind of plane we're going to make. Usually this is because it's the easiest plane to make, or our best plane, or the only one we know. A computer doesn't really have the ability to think in the same way as you, but it can still make choices. If you program the function, paper aeroplane, and you tell the computer the commands to make 4 different types of paper aeroplane, you could ask it to choose one of those designs at random. As long as it has all the information, it can complete the function. As humans, we can learn to make new styles of plane, which give us more choices too. So while it can take time for us to learn commands for a function, once we know them, we rarely forget them, even if it's been a long time since we've done it. So let's try following these instructions to make a new type of plane. Remember, you can pause the video whenever you need to complete each command for the function. So you need a piece of paper. Turn that paper to the right. Now fold it in half widthways. Open it out. Fold it in half lengthways. Open it out. Fold the top corner down to the crease in the middle. Fold both corners so they touch the bottom of the flap and crease in the middle. Fold the top down. Fold the top down again. Turn the plane over. Fold it in half from left to right. Fold back both wings along the dotted line shown here, and your glider is finished. Now, if you redo these commands over and over, the paper glider will become a new function, so that when you're asked to make a paper aeroplane, you have a choice of other functions you could use to complete the task. Once we know something, some people use the phrase, "It's just like riding a bike," which means we don't forget it. Think of how long it took you to learn to ride a bike. But now you could ride any bike, just because you know how to complete the function and your brain doesn't forget. Speaking of not forgetting, show this picture to an adult in your home. Do they know what it is? Pause the video and see if they can remember how to make it. This is a fortune teller, and your next challenge is to learn how to make this and act like a computer. I'm going to give you the commands to make a fortune teller. Once you learn how to make the fortune teller, you can test it out on people. Your job is to be the computer. The person you ask will choose a colour. You must spell this out and open and close the fortune teller. Then the person will ask you to reveal the number, and you must count this out and open and close the fortune teller. And they will choose a number, and you must open the fortune teller and reveal their fortune. Let's go through the commands for how to make one and test it out so you can see how this works. Remember, you can pause the video at any time while you make the folds. So to make a fortune teller, you'll need a square piece of paper. You can start with an A4 piece of paper and fold one corner like this. Then fold the other corner. Cut along the top line. Get an adult to help you if you need to do so, because we don't need that piece of paper. You are then left with a square piece of paper. Fold one corner to the centre. Then fold the remaining corners to the centre. Turn it over and fold a corner to the centre. Then fold all the corners to the centre. Now turn it over and see if you can insert your fingers and test the fortune teller. You're going to colour the outer pieces in a different colour and number the 8 inner pieces from 1 to 8. Then write 8 different fortunes or messages under the flaps. And play and enjoy. Pause the video and have a go at making another fortune teller without the instructions and see if you can remember the function fortune teller. Now let's look at how we could connect this to our real world. Throughout the next 24 hours, your challenge is to think about everything you do as functions and maybe create a sketch note of your day. It could look something like this. Remember, a function is a series of commands. So make bed or set table or brush teeth involve a lot of steps to complete it. Share your sketch note with everyone at home and upload it to your platform for your class teacher to see. In our next session, we're going to look at repeated patterns in what programmers called for loops. So, see you next time for session 3 on computing at home.